In 2021, we launched the most important investment in the history of the University of Missouri. It's called Mizzou Forward. It's a $1.5 billion 10-year investment for us to achieve excellence in student success, research excellence, as well as engagement with the community and the state. As part of Mizzou Forward, we wanted to identify areas that are grand challenge problem for society. And we knew that we had outstanding faculty members working across many different schools that are focused on materials. We were able to launch the institute that supports materials research, but also materials engineering. And we're very excited about that investment.
So the Materials Science and Engineering Institute offers a wide range of research, and I think our particular strengths include areas like nanoscale materials and nanomanufacturing, biological materials, materials under extreme conditions, and also semiconductors and quantum materials.
A unique aspect of the Institute is that it's an emergent grassroots effort. As a campus-wide entity, it brings people together from all across the university with lots of different research interests in a way that integrate efforts from different disciplines.
The one area that I'm particularly passionate about is carbon nanotube materials. In my research group in particular, we are looking at synthesizing carbon nanotubes directly within a scanning electron microscope, and that allows us to look directly at the assembly process of the carbon nanotubes as they grow, and that's ultimately what determines their final material properties. And so with that capability of viewing the carbon nanotube assembly process, we also have a simulation component which allows us to integrate both the video and the simulation to back out mechanical forces and the processes that are driving the assembly of carbon nanotube forests.
In the area of multi-scale materials simulation and design, what we do is we start at the fundamental building block scale of materials, atoms and molecules, and we perform simulations on the nanoscale for these sorts of materials and extract properties, understand processes, take what we've learned, transfer that up the spatial ladder to materials on roughly the micron scale, and do similar things, but now the physics that we have to incorporate is different because we're on a different scale. And we do this as we work consecutively up the spatial scale until we are able to make predictions for macroscopic pieces of material doing interesting things.
We work with a range of materials here, and some of them involve quantum materials such as, with which you can make a single layer quantum magnet or cloning of Dirac states. Again, new material platform for spintronics, development of organic semiconducting and hybrid perovskite semiconductors with which we can make low-cost optoelectronics such as organic or perovskite solar cells and light-emitting displays. So in the current climate crisis that we live in, this research has a lot of impact. It has the potential of fast and highly energy efficient electronic devices.
The Materials Science and Engineering Institute is going to expand Mizzou's impact in this important area of biomaterials. So where my research fits into this picture is that my group builds large-scale computational models that reveal how physical restructuring of protein-like clusters underlie neurodegenerative disease, really a material science rather than a genetic process, which promises future treatments that are simple yet universal. We've also built the world's first and only physics-based model of a biological cell that sheds new light on the matter-life nexus, helping us to understand the origins of life itself.
What I hope to see in the future of the Institute is a thriving research and academic program that brings more and more diverse groups of people together to tackle problems that in the past would not have been practically achievable at the University of Missouri. Through its role as a hub, we think that this is definitely achievable.
A key aspect of Mizzou Forward is hiring faculty members that are nationally recognized in their field. We look forward to hiring many faculty members throughout the many departments in both arts and sciences and engineering to support the growing research programs as well as the growing graduate and undergraduate programs that will attract top students to the University of Missouri.
Right now is a very exciting time to be at Mizzou with respect to materials research. We have a rapidly growing materials infrastructure, both in terms of traditional characterization and also a state-of-the-art electron microscopy center. We have unique tools that allows us to interrogate materials at even the atomic levels while we're doing experiments, and I think that's very unique specifically within our region. And I'm just very excited about the growth of our academic programs and integration of materials with things like artificial intelligence and machine learning. I think we're rapidly gaining a lot of traction in many areas.